I thought, so this is the panel you've all been waiting for. AI and governance. I thought I would just read a few sentences to frame the panel, and then I will introduce the panelists, and then we'll get on with the questions for the panel. And I will leave time for questions from the audience. AI technology already pervades our daily lives. It is used in movie recommendations, targeted advertising, face recognition, and sentiment analysis. More and more, we will see its use in systems that will be making decisions about people with life and societal consequences. For example, diagnosing disease, driving our cars, delivering our packages, determining bail, and detecting terrorists. While the success of AI technology and its astonishing applications are incredibly exciting, its very ubiquity gives us good reason to pause. Should AI be regulated? If so, what would it look like? Who should be involved in specifying the rules and enforcing them? This session will address these fundamental questions. So panelists, are you ready? On my far left is Ronaldo Lemos. He is a Brazilian academic, lawyer, and commentator on intellectual property, technology, and culture. Their bios in your pamphlet, so I'm not going to read the whole paragraph. So Ronaldo Lemos has a JD from the University of Sao Paulo Law School, a Master's of Laws degree from Harvard Law School, and a Doctor of Law from University of Sao Paulo. Next, we have Eric Talley. He is the Isidore and Sybil Solbacher Professor of Law and co-director of the Milstein Center for Global Markets and Corporate Ownership here at Columbia University. He's an expert in the intersection of corporate law, governance, and finance. He holds a JD from Stanford University, a PhD in economics from Stanford University, and BA degrees in economics and political science from the University of California, San Diego. Next, we have Joanne Stonier. She is the Chief Data Officer for MasterCard, in charge of all of MasterCard's information assets, ensuring the availability, quality, accuracy of data for innovation, while balancing the use of data with risks. Her position is global. She's had many previous positions, including at MasterCard. She holds a JD from St. John's University in Queens and a BS from St. Francis College. And finally, we have Daniela Roos. Daniela Roos is a personal friend of mine, so I'm really glad that she was able to make it. She is the Andrew and Erna Viterbi Professor of Electrical Engineering and Computer Science and Director of the Computer Science and Artificial Intelligence Laboratory at MIT. Daniela is very well known for being a world's leader in robotics and AI. She earned her PhD in computer science from Cornell University and has many academic accolades I won't enumerate. So, okay, now I'm going to sit down and ask questions. Oh, now you can't hear me as well. Can you hear me? Yes. All right. Okay, so I thought we would start with just framing where we are in terms of technology, where we're going, and then start asking the questions about regulation. Does it even make sense to regulate, and what would regulation look like? And what would governance more generally look like for AI? So naturally, I want to start with Daniela, who is, as I mentioned, one of the world's experts in AI and robotics. So Daniela, I thought for the purposes of level setting for the audience, it would be good if you were to explain the current capabilities and limitations of AI and data science technologies, and then expound on where's the technology going? What are some trends for which maybe we can get ahead of in terms of governance?
Hello, everyone. Thank you for inviting me to be on this panel, Jeanette. I am so excited to be here to tell you about AI. And I would like to take you 20 years ago. So think about where you were 20 years ago in the state of the world. So 20 years ago, the idea that we would have pervasive computing was a pipe dream that belonged to a number of dreamers in computer science. But 20 short years later, we depend so much on computation, we don't even notice it around us. And I believe we're about to experience an equally profound change in our lives, only this time it will be AI technologies supporting us with cognitive work in the future and robotic technologies supporting us with physical work in the future. The potential is amazing. In the future, you can imagine no more car accidents. You can imagine personalized healthcare with better engineered medicine, better monitoring and personalized treatment of disease. You can imagine better transportation of goods with lesser impact on the environment. You can imagine keeping our information private and safe. You can imagine really offloading routine tasks to machines and allowing people more time to focus on applying expertise and critical thinking. So these possibilities are being opened up by the field of artificial intelligence. And AI is a very broad term. But really, when people talk about AI, they usually mean three different things that are subfields of computer science. So they mean artificial intelligence, which is about making machines with human-like characteristics in how they see, how they communicate, how they move, even how they learn. And then there's robotics, which puts computation in motion. And there's machine learning, which cuts across both AI and robotics. And at least today, it's about using data to make predictions and to find patterns. And together, these technologies are set to provide huge impact. And in particular, every field that has data is likely to benefit. But we kind of have to keep perspective onto what machines can and cannot do. So with data, machines are really good at looking at vast amount of data and finding patterns much better than we can with our naked eyes. And I just want to give you a quick example from medicine because many of us can relate to healthcare examples. If you think about radiologists, today machines can look at more radiologies in a day than a radiologist would see in a lifetime. And in a recent study, when machines and people were given scans of lymph nodes and were asked to classify them as cancer or not cancer, the error of the machine was 7.5% as compared to the human error at 3.5%. But when they worked together, the humans and machines achieved 80% improvement. And that is because machines are better at some things and humans are better at other things. Now, the potential for these kinds of technologies is huge. Today, it's mostly the advanced hospital centers in the world that use these techniques. But in the future, imagine a future where every doctor has access to these technologies. Every doctor has access to the latest advances in natural language understanding and the latest advances in pattern recognition enabled by machine learning. These doctors will be able to provide their patients with personalized care in real time, taking advantage of the latest and greatest studies, even if the doctor doesn't read those studies. But this doesn't mean that today's technologies can solve anything and everything. In fact, there are significant limitations to what machine learning can do today for us. And these limitations pertain to the fact that most machine learning engines require massive data sets to train. Not only that, but these data sets have to be labeled by people. So if you work in a field where you have millions and millions of data points that people painstakingly in crowdsourced settings can sit and label, then you can train a machine learning engine to do what it's supposed to do. And these machine learning engines are huge computations. Also, when machine learning engines provide an answer for you, the answer does not come with an explanation. You have no idea what the machine said, what it said. You can look at other examples and you can say, yes, it seems reasonable, but we have no idea whether in the future we will have the same good result. And this is a significant challenge because making interpretable decisions, especially when people and when the world depends on those decisions, is critical. And this is a place where regulation is super important because we have to put in place processes and ideas to ensure consumer confidence. So this is a challenge. The performance of the machine learning engine is only as good as the data that is used to train it. So if there is error or bias in the data, that's what you're going to get from the machine learning engine. How can we ensure that the performance is not biased and the performance is fair? These are big fundamental questions that the computer science community is working towards answers for, but we haven't reached there. Nevertheless, we still have techniques that can do better than people. A few other limitations. Crunching through data does not translate into knowledge. Just like doing a lot of computations is not about autonomy. So we kind of have to keep these into perspective. Another thing is that today's machine learning engines are primarily by experts only. You have to know how to turn the knobs in machine learning engines. It's not even enough to have a computer science degree to know that. Although there are companies and universities that are increasingly aiming to democratize what is possible, and you can fool the engines quite easily. Further, the final example I will give you is you don't need a million examples to know that you are looking at a glass of water. In fact, we as people learn from single-shot experiences, and so thinking about how to change the algorithms to be more human-like, to depend less on these vast quantities of data is again something that we cannot do today. And so, in summary, machine learning is primarily about finding patterns in data, predicting what might happen, and suggesting action items, but at a very, very low level. What we would like for the future is to understand the nature of intelligence and understand how to bring deep reasoning into the systems that we build.
So Daniela, thank you for that incredible summary of where we are, state of the art in AI, machine learning, and so on, and hinting at where we might need to look at the governance of AI, the regulation. In particular, a lot of these machine learning engines, as you call them, are now being used in, say, US court systems, in government agencies, to make decisions about people. More specifically, very recently, the president of Microsoft, Brad Smith, has called for the regulation of face recognition technology, specifically, and face recognition technology is all driven by this AI technology that Daniela mentioned. And so I thought that we would start with, should AI be regulated before we even go on to what would that look like? And Joanne, I wanted to start with you because you've been in this conversation with industry, government, and academics and nonprofits. And so I thought maybe you can share with us what those conversations have been.
Sure. So I've been listening to today's conversation avidly. And at MasterCard, we are engaged with lots of different policymakers and regulators around the globe, both on AI and on regulation generally. And I have to tell you that I've been sitting here thinking that we really need some super regulators to handle all of the regulation that we want them to handle, given all of the conversation today. So I'm looking forward to finding some of those folks because they have an awful lot to handle, given everything that we want the regulators to do. Before I was the chief data officer for MasterCard, I was the chief privacy officer for MasterCard, and I worked with data and protection authorities around the globe. And I have to tell you that they're currently struggling as the GDPR hits its 1-year anniversary this month just trying to figure out how to enforce and understand the implications of that law. And so when you think about what Brad Smith was talking about with facial recognition, and I brought up my iPhone on purpose, right? Because my iPhone, and I can't quite get it to lock itself, right? It unlocks with facial recognition software. And many of you are using that every day, right? And so that is an example of AI in action. And we're increasingly using it and thinking about it as we navigate our world. But I think we have to be careful about regulation in all forms, right? And I think we're having these conversations with everyone from the EU, who has a task force on the EU ethical guidelines on trustworthy AI. We've worked with the Monetary Authority of Singapore to develop fairness, ethics, and accountability on artificial intelligence. We're participating with the United Nations on this topic, as well as with the OECD. And why aren't we seeing regulation come out right away? It's because of what Danielle is talking about, and it's because of some of the issues that you heard the previous panel talk about. Artificial intelligence is in its early stages, and yes, everybody's worried about the volume, the veracity of the data that's needed in order for the models to train and learn. But then what is the framework that needs to be talked about, given all the different contexts in which the data can be used? So when you're talking about facial recognition, that's an incredible amount of personally impactful AI. But there's plenty of other examples of artificial intelligence where the artificial intelligence isn't personally impactful, right? So if we're talking about the amount of crunching that can be done on weather patterns, right? It's not necessarily personally impactful. And so should we have the same type of regulation on that type of artificial intelligence, which would be using the same volume of data, but it wouldn't necessarily be as personally impactful as facial recognition and how that information might be used? So what we're doing at MasterCard around this issue is we're first working on voluntary frameworks that my company is leaning in on and trying to figure out with my data scientists, how do we want to be navigating the world of governance around artificial intelligence? And so you have to really break down some of the processes that Daniela was really doing a great job of explaining. So first there is the training data. And so right now, the first days of artificial intelligence is the volume of information that's being fed into whatever the model is that you're trying to train and the intelligence or the machine learning that's happening. And so how do you look at that data? Today's discussions, we've heard all sorts of things about data, but we haven't talked specifically about it. Accuracy of information, veracity of information, lineage of information. Are all the things you're feeding in. So it's one thing when you're feeding in images, but is the data you're feeding, we do a lot around fraud and safety and security, right? When you think about the payments that go through our systems every minute of every day, we're trying to spot what are the valid payments, what are the fake payments, what's valid data, what's invalid data. That becomes super important as we're trying to train our models. So we need to make sure that the data we're training is accurate information. And in the world that we're now living in, the first wave of the internet, we were all playing kind of fair and square. And what we're learning now is not everybody's playing fair and square anymore, and especially the bad guys. They're getting really good at feeding in fake data, inaccurate information that looks awfully accurate, that looks like it's coming from legitimate users on our system, legitimate transactors. And we have to get really good at spotting what's real and not real. And then those models, so all of that training data goes into models. Daniela was trying to give you a sense of then what do you do once it's in the box and the box is learning? Well, we're starting to do things like using AI to observe AI. That sounds very scientific, but it's really, the model itself is doing the fraud algorithm. We're trying to have another model observe that model and spit out a report so that my scientists, my data scientists, can actually begin to see, is the drift legitimate because we're actually seeing a location where fraud is really happening because some cyber criminals have set up shop and they're actually doing something? Or is there drift happening because our models got it wrong? And so it isn't because I have green eyes that I'm actually committing fraud, but because there's something actually going on, or that our models took into account too much, that green-eyed people just accidentally committed more fraud, right? It's not a true cause of fraud, it's an accidental cause of fraud. But it does require a partnership between the algorithms or the technology and individuals observing what's coming out of the box. So we're trying to create an entire ecosystem. What's going in, the models, what's coming out, and monitoring for all sorts of bias. We worry about discriminatory bias because as individuals, we worry that we're going to go after the green-eyed people or people of a certain race, country, ethnicity, something that's individually impactful. But we also have to worry about all sorts of biases: automation bias, confirmation bias, coverage bias, experimentation bias, group attribution bias, implicit bias, non-response bias, sampling bias, and a whole bunch of other technical biases that I know and understand. And if you're a group of computer scientists, I'm happy to have that conversation with you. But these are the things that regulators need to understand if we're going to have regulation in this area. And this is the convergence of technology and law. And so if you have kids, tell them to take those two majors, okay? Because the data scientists and the lawyers have to get together for this to be a place of real regulation that's going to be impactful for society. We can't have it done at a high level. It has to be people who understand the data so that when we have people in court, and we will, right, that we can have testimony before judges, tribunals, and regulators that makes sense. So where do you begin? You begin by having responsible companies lean in and come up with samples of how to do it. You disclose how you're doing it to the best you can. And then you go from there in building regulation that makes sense for society. But we're at early days, but we have to do it now. Because if we wait too long, the boxes are keeping on learning, guys. And if we don't figure it out now, it'll be too hard to do it later.
So Joanne, that your statement about the technology people having to get together with the lawyers is a perfect segue to our two lawyers on the panel. And I'd like both Eric and Ronaldo to respond. We're kind of, to be honest, the technology community is looking to the legal community, the policymakers and so on, to help us think about what it would even mean to regulate AI. And so Eric, why don't you start us off, and then Ronaldo, you're next.
Yeah, sure. I want to be also mindful of Ronaldo's bewitching hour. So first of all, let me thank you for having us here. This is already proving to be a very fascinating panel to me. And I also definitely want to join with Joanne's encouragement for you to encourage your students to go to law school, where they will increasingly confront a group of faculty who themselves are trying to beseech students to become a little bit more woke to AI, to machine learning, and how it may apply both to law and how law may apply to it. My personal path, when Jeanette was reading my own sort of background, it has not been an AI background. I'm more of a sort of a corporate law and securities person. I'm an economist as well, but I've always been sort of a nerd at heart. And one of the things that became very clear to me in doing what I do, which is sort of empirical analysis of corporate and securities law, is that lawyers are among some of the best producers of unstructured and semi-structured data in the universe.
That's true.
I mean, yeah, there are sort of galaxies and DNA sequences, but lawyers are probably third on the list, and it's very, very difficult using sort of conventional means to sort of understand, organize, and pull patterns from it. And this area has been so powerful for me that it's essentially commandeered my entire research trajectory in basically good ways. So thinking about disclosures, thinking about how do you ferret out insider trading patterns? There are just all sorts of pattern recognition issues that AI is helpful for. When it comes to sort of the intersection of AI and law, I think there's probably two ways to think about it. One is, how should the legal system think about regulating AI in general and its uses within industry? The other one that we're spending increasingly, and I want to talk about both, but the other one that we're spending increasing time thinking about is how is AI going to have an effect on the administration of justice itself, and how substantive law changes, how courts change, what a court will look like in 80 years. So let me just pick off both of those, and then I'll hand it over to Rolando. So first, the regulation of industry or actors who are themselves using AI technologies is obviously an important issue. Privacy issues are, have dominated in recent years, and it's quite difficult in some cases for large actors to even be able to ensure the integrity of their own privacy protection systems. Google and Facebook have been very much at the front of the newspapers recently, but this is a problem that faces essentially everyone. And one of the things that's actually quite difficult within law is that, and Jeanette, you and I have talked about this many times, is that law itself has a couple of sort of ground rules or general principles about privacy. But I think even within law, there's a lot of work to be done in trying to understand what are the objectives that we are trying to accomplish through privacy. And I think Joanne was sort of backing into it about saying, well, look, weather patterns, how much privacy concern would we have about it, consumer credit, maybe something else. A second issue that is increasingly coming up with the application of AI to various types of decision making, and I think in the financial services industry, it is almost certainly a dead center, is it possible that your algorithms, that your learning algorithms, are going to back in various types of decision-making criteria that over the last 70 years we have learned are impermissible decision-making criteria. And even if you don't say, well, we've got a borrower who's applied for a loan and we're going to keep race, ethnicity, gender, sexual orientation out of the underlying data that gets fed into the model, there's no guarantee that a machine learning model won't latch on to a very, very close correlate that's functionally the equivalent of exactly those same impermissible criteria. There's a huge problem right now, and it also makes us sort of back up and try to figure out, okay, what are the underlying commitments of things like anti-discrimination law, and how far are we willing to push those boundaries? And in some cases we might be willing to. In other cases, I think the answer is almost certainly not. The other thing that's getting a lot of attention these days by myself and other folks is how is machine learning and artificial intelligence going to affect the administration of law itself? There are all sorts of folks out there within industry and amongst academics who are proclaiming, and by the way, I'm a fanboy of AI, but I worry a little bit about this, that the court of tomorrow will consist of essentially no humans whatsoever, and that all we have to do is
the defendant?
Maybe, yeah. So all we have to do is sort of figure out what the patterns are within our current judicial system. A computer's going to recognize that far better than a jury or a judge, and it'll be very fair. So let me just advise a little bit of caution about this, and I think this is one of the discussions that computer engineers and legal scholars and lawyers need to have with one another. There is a sense, it's a fable, by the way, but there's a sense that even my first-year law students have on the first day of law school, that the law consists of what is essentially an engineering system. It's a whole bunch of rules. They're very complex, so it's going to take 3 years and $210,000 to learn all of those rules. But once you have mastered those rules, you have mastered the law. And almost every one of my first years comes in, and this is their view of what the law is. And they could not be more wrong, all right? And the problem is a very, very smart computer scientist who says, I'm going to tackle law, they're smart, but they're probably going to think of it in the same way. And here's part of the problem with that. First of all, any set of rules is going to be woefully either over-inclusive or under-inclusive. In any system of rules that you try to set up, you're not going to be able to identify a unique outcome. Sometimes the rules are contradictory. Sometimes they leave too many things on the table, and then something else is going to have to make up a decision. Second, the legitimacy of law hinges not only on consistency, but on some other stuff too, all right? The application of some set of legal standards has to make sense from a policy, from a normative perspective, and those normative perspectives aren't necessarily static, non-moving targets. They can change over time, and law has sort of built in within its own circuits the ability to adapt to a changing set of commitments of what is and isn't important. And it's not going to be particularly helpful to say, well, I've analyzed all of the outcomes since 1950 to be able to predict what's going to happen next year if, in fact, something changes in our normative commitments. And you think about some of the most important cases that we celebrate today, right? Marbury versus Madison, or Brown versus Board of Education, or Gideon versus Wainwright. These cases are important because they broke with a pattern, because they ended up pushing in a direction we didn't really think about, and then suddenly, oh, that makes sense. I might be able to rationalize it against some of the previous cases, but maybe not. And then I guess the final thing that I'll just put a little plug in and come back to this is that as AI penetrates our everyday lives, and it will and it is, it's also going to affect the way that we think about how we want to structure law. So I've been working with a group of people here at Columbia on how to think about automobile liability in this is going to sound like a boring movie trailer, in a world where there are autonomous vehicles and humans interacting with one another. All right. In some ways, the engineering problem is easiest if the only thing you got out there are AVs. But if it's autonomous human interaction, which quite frankly is here to stay because there are always going to be bicyclists and there are always going to be pedestrians, this turns out to be a very hard problem, and it forces us, without going into excruciating detail, to rethink how do we think about negligence law, products liability, various types of products regulation, and how do they interact with one another, is almost certainly going to be the case that the model that's developed since the advent of the automobile is going to have to undergo fairly dramatic and rapid change over the next 30 years. And there are a whole bunch of people, including myself, who are trying to think through some of that stuff.
This is great, Eric, and we will return to some of that later, and Danielle actually wants to comment on your remarks, but Ronaldo has a full hard stop, so I want Ronaldo to comment on what you've heard so far and your take on sort of regulation of AI.
Sure. Thank you, Jeanette. Can you hear me?
Yes.
Okay. So since you mentioned my affiliation with Harvard, I have to say that I'm a professor here at Columbia.
Okay.
I'm a visiting professor. And the name of my course is precisely Technology Policy in the Developing World. So basically, one of my tasks is how do you translate these debates into the context of the developing world, because they change completely. So I have like three very quick examples that I think can show a little bit how AI is not a problem for the future of the developing world, but is also something that we have to deal right now. So the first one, the state of São Paulo, Brazil's richest state, has been using chatbots to automate its interface with the citizens. And it's great because it's actually very efficient. And you go to one of the state's websites, there's this little guy over there. It's a chatbot. It answers your questions super fast. And a lot of people don't actually realize they are interacting with a machine. And the other thing is, how is that data governed? What sorts of stacks are actually being used there? And of course, this is great for the government because it saves a lot of costs and it's going to spread very fast. But I don't think we have talked a lot about governance yet. So this is going to caught like wildfire, but it's something that the conversation about governance maybe will happen only after the fact. So that's the first point. Second point is that in the developing world, the problem sometimes is not huge amounts of data, but it's the absolute lack of data. There are so many blind spots regarding certain types of population. Data is like missing regarding so many different things that actually makes the AI stack imperfect.
That's right.
So one example is maps. Take for instance a city like Rio de Janeiro, in which a lot of people live in shanty towns. If you go to Google Maps right now, you look at some of those areas and you see like a park or a green area, and you say, great, there's a park here. There is not. There's like 1 million people living there, you know? And there are like streets, and there are like supermarkets and shops and so on. So AI is built on top of a very complex stack. And if you don't have the underlying elements of that stack, you're going to have a lot of dysfunctionality. The third thing that I would like to mention is about deep fakes. So you can use AI right now to create very perfect forgeries. You can create video, you can create the images of politicians, and this is something that will put a lot of pressure in these discussions we were having here regarding manipulation and elections and so on. So Brazil is coming out of a very complex election process in which there was a lot of automation happening. Our institute in Brazil published a paper demonstrating what types of automation was happening in Brazil. And Brazil is very funny because we always do the wrong things first before everybody else. So in Brazil, I would dare to say that we had the first deep fake case in an election. So at a certain point in the election at the state of São Paulo for a governor, the governor of São Paulo got this weird video basically going viral. I'm not going to describe what the video is, okay? You can Google that later. But it's something that puts him in a very complicated situation. And the video is not clear, so it's very hard to see who is the person in that video or not. And I've read 2 different expert reports, one of them claiming the video was true, and the other one claiming that the video was clearly a deep fake manipulation for a lot of reasons. If you ask me whether it was true or not, my answer is I don't know. The fact that deep fakes exist make me in a position in which I have to doubt, and I don't have any clue whatsoever about whether that video was true or not. So my point is, for AI to go forward, it will have also implications regarding elections, media manipulation, and so on. So how do you approach AI governance? In my view, I come from many years of work in internet governance, and the approach that I think Brazil put forward, and I think it's a successful one, it's a multi-stakeholder approach. So if you leave this just for the state to regulate, it's not going to be effective. You have to build a coalition that involves the private sector, the scientific community, non-governmental organizations, and the government, and they all have to talk to each other to come up with a solution. If you leave this just for your typical bureaucrat regulator, it's not going to work, it's not going to be effective. So that's a little bit of my take.
Good, thank you, Ronaldo. That was fascinating. We did want to talk about developing countries versus the developed world, so I'm glad you brought up those points. Now, Daniela has been chomping at the bit to respond to some of the comments made, so Daniela.
Well, I'm actually very excited to see that at MIT we have very similar approaches, and so these partnerships and alliances you're talking about for Brazil are exactly essential for moving forward. So here are some observations. If you put a machine in a decision-making process, you really have to have a set of tests that ensure that you understand the performance of the machine. So everything that has AI in a critical decision-making path requires a kind of a test. Think about it as kind of a driver's license-like test. So if you bring the program into the system, check the program out, just like you check the skills of the driver. And I think, so at MIT we have an institute for policy and privacy. It's called IPRI. And our thinking is that there are certain generic attributes that you would like to test your system along. And the specific questions you ask in the context of these attributes varies across industry, but the attributes are the same. So one of the attributes is explainability and interpretability. So if the system denied a loan, why? Or if the self-driving car had an accident, why? If there was a diagnosis in healthcare or somebody was denied bail, why? So this is the first one, explainability and interpretability of the decision. The second one is on privacy. So if you need data to tune your system, how do you ensure that those who provide the data for the greater good actually are protected? And how do you ensure there's no bias? How do you ensure there's fairness? And how do you ensure there is clean data provenance? So these generic attributes can be instantiated in each industry, and so maybe creating the correct driver's license-like tests is a way to go. Another important observation is that there should be a close interaction between those who understand the technology and those who understand the policy and are responsible for policy, because in many cases the technology can produce some solutions. In fact, we in computer science often feel that we have created this big mess by enabling a lot of data to be used around us. And we ask ourselves, what can we do to get us outside of this mess? And there are technological solutions. People in computer science are working on differential privacy to ensure that if somebody provides data for the greater good, that data is, or the identity of the person is protected. We are developing something called homomorphic encryption, which is a mouthful, but this says that in the future, we will be able to compute on encrypted data. And so if only you can detect your data, you can decrypt your data, you can provide all of that for the greater good without worrying about your own privacy and security. There are also people working on secure multi-party computation where people could aggregate together to do something without revealing anything personal. So this is another important thread. And the third thing I would say is that if we get the technology right, some of the problems might go away. So in particular, because I work a lot on self-driving cars, I'm just compelled to have to tell you that the day when we have perception and control that are really accurate for autonomous vehicles will be a day with no accidents, because the car will have access to information way outside of our perception domain, and will just know ahead of time what to do, and will be able to not have to choose whether to kill one person or another person depending on how to veer off. Now that day is not here yet. But we're working towards it.
Yeah, I feel like after you were talking about the privacy-preserving technologies, which I just taught a course on those technologies, I felt like there was going to be a however from the legal and policy world. We technologists love to invent technology and solve things with technology, but there's usually a however.
Yeah.
So I would like to hear from the others if there is such a however, and also, Eric, if you want to go back to the autonomous vehicle accident law example, Daniela queued you up for that. So, Joanne, do you want to comment?
I'm in such a duality on this because
that's why you're sitting in the middle.
I got that. We use a lot of these technologies as well. We use homomorphic encryption. We use differentiated privacy. I think one of the things that I really want to get across is that responsible actors start with very basic, really good information practices, right? And we haven't really talked about that much, but I mean, we've talked about what are some of the practices, but you have to have really good information practices to even be dabbling in any of these businesses, right? And so I hear all of this, but I think every single one of these things has its limitations, right? And we're talking about them in the hands of very responsible companies and organizations, academic institutions, and when they're being used for good, right? Then you wind up in a place where they can advance innovation, and we're trying to do things in the right way, trying to put, at MasterCard, we always talk about putting the individual at the center of the narrative, right? What are we doing and what's the implication for the individual, right? Can you explain it to your grandmother? When we talk about, we have a whole program for data for good for society, and we're always looking at, do we have sufficient information, right? So, Ronaldo, your point, right? That's one of the blind spots, right? Are we going to get to bias unintentionally because the data, even though we have all of the algorithms that protect from the actual bias? Are we going to wind up with unintended bias because the data is going to lead us back there? All of these things are part of our DNA. The challenge is going to be, though, that there are equal actors out there that are going to use these techniques for ill. And we know that because we are constantly monitoring our network for the bad actors trying to get in, right? There's incursions happening right now at MasterCard. We have a center that's magnificent to watch as we watch all the bad incursions trying to get into our network over and over again on any given day. And so I worry that, that the world is going to continue, but that world is also going to continue. And so there's both things that we have to look out for. And it's complicated, and we're making it even more complicated. The other thing I want to say about regulation is we oftentimes get very myopic about digital giants. And we talked a little bit about small companies today. But I think we have to be mindful that there's all sorts of organizations that are going to move society forward. I work for a large company, a global company. We have not talked about the different contexts of different global economies, different types of cultures, different types of data contexts. All of that has to be taken into account. And so when we talk about regulation and we talk about all these different tools at our fingertips, that also has to be taken into account, right? So just because we are sitting here at an American university, we have our own set of biases in what we think is right. And in another culture, we just did a really interesting course about if you're in a car accident and what the cultural bias would be about lying for your friend in different cultures. And there's a huge difference if you're a US citizen versus one from China versus Italy, and what the expectation would be. And so, I won't go into it, but it really is very different depending upon how you've been brought up, right? And I'll just say that someone from another country might think that you are a terrible friend if you don't lie for them. And so all of that goes into the mix on this. So it's not so easy. We say, oh, we're going to have the regulators do it. Not so easy.
Eric, did you want to respond to any of these comments?
Maybe just really quickly. First of all, the desideratum of explainability, I think when it comes to legal applications, is critical. So reason giving is often thought to be one of the most important parts of legitimacy of any legal system. If you can't give a reason for an outcome, it can be amazingly consistent, but it's not necessarily going to garner an awful lot of support. On the but what about sort of question. So this is this. Ronaldo and I are now going to demonstrate why so many people hate lawyers, because we're the ones that are supposed to worry about all the different things that are hiding around the corner. And let me just give you a couple of thoughts. Yesterday, I was doing what you were doing today, Jeanette. I was moderating a panel with the former general counsel of Apple, Bruce Sewell, and the current general counsel of a large financial services company. And we started getting into, Bruce started talking about the fact that you may not know this, but in your iPhone, there's a capability to pick up small, almost imperceptible vibrations and oscillations in the way that you're holding the phone. So much so that it's sufficiently accurate that this would be a way to detect early Alzheimer's, or early Parkinson's, excuse me. And so, and then the other panelists said, oh yeah, we actually will sometimes use various pieces of input from an iPhone to kind of get a sense for markers for various types of fraud or default likelihoods. Every one of these might portend what is effectively, and maybe even unwittingly, the use of a protected class to make predictions in ways that are going to get you in trouble in ways that you may not even realize it. So I think that there's, we come by our unpopularity or lack of popularity, I guess, honestly. Last thing, and I want to sort of push, probably for the sake of the audience, this sort of autonomous vehicle sort of idea. I think that there is, in some ways, I agree that at some point that there may be this magic moment where we realize that we've got the sensors, we've got the computation, we've got the equipment down to make this sort of one big harmonious symphony of autonomous vehicles driving around. That said, I'll just go back to what I noted earlier. those aren't going to be only things out on the streets. There's going to be pedestrians, there are going to be cyclists, and if you actually kind of put these folks into, I'm going to take my powdered wig off and put my economist pocket protector on. If you put that in a game theoretic environment where you sort of realize, oh, I'm about to enter an environment where things that could have hurt me with great probability 20 years ago are going to hurt me with much lower probability today. I'm going to take more chances, and it's going to be rational for me to take more chances. And so when you start thinking through how does that strategic interaction work, I'm not saying the magic day won't come, but I would like to suggest that it may be further off than thinking sort of statically about how people behave right now. It's going to be, right? I think we're going to have to adapt to the adaptation
that's
of
right.
AVs.
That's right. So and putting the robotics work together with the work in economics and the work in social behavior is absolutely critical. And I'm very excited to tell you that, in fact, there are new advances that are really addressing the building personalities and building people characteristics fundamentally in the control engine of a car. But these remain technical papers right now.
Ronaldo.
So very quickly, because I have a flight to China to catch like very soon.
I did want to bring up China, but not in that way.
So I think like data science is the point here, right? So I was reading this paper the other day in which someone figured out that if you write in capital letters on social media, you're probably not good to pay your loans, so you have to have your credit score decreased. So that's the type of analysis that we are going to see more and more throughout this issue. And I really think we should ask the question, how many data scientists we have in the government right now, for instance. For the US, I think probably the answer is not too many. For the developing world, it's probably 0. And I really think we should start like getting more data scientists in the government, but more than that, building bridges between the government and the data scientists themselves, because I think we need this debate and this conversation to start as soon as possible. So that's one quick point. The other quick point that I would like to share, in Brazil, we started this project called the Law of AI. So basically what we are doing is looking at the legal system and seeing what we already have that has an impact over the AI stack. So what is it that regulates the cloud? What is it that regulates explainability, the outcomes, consumer protection? So without having to change the law at all, just when you put all these different pieces of the law together and you already see what is the corpus of the law that applies to AI, I think this is very helpful. And because the AI stack is very complex, you will see that the legal norms that we will apply to that is actually there, it's very complex too. So knowing that, I think, is also a starting point to basically asking the question, is there something else that we need? Is there something that we need to get rid of? So having that in mind, I think that helps quite a lot also to think about the governance of AI.
I wanted to, I do want to save time for questions from the audience, but there is one topic I wanted to touch, especially because this is about global digital forum. And this has to do with AI in China versus AI in the US. So I think, again, I'm going to turn to my world's expert in AI and robotics to give us a grounding in terms of technology, state of the art in China versus the US. Do you have a position on that, Daniela?
Yes, I do. I've been going to China for a number of years, and I am just so impressed by the rapid development in China, by the limitless, infinite quantity of money, by the ambition and agility with which things get done. If you haven't seen Kai-Fu Lee's book, AI Superpowers, I recommend it to you. And so we see great development in China. We see huge resources.
Data, too.
In data, so yes, I'm getting to that. We see huge resources. We see the government declaring that by 2020, China will catch up. By 2025, China will get ahead. And by 2030, China will be a leader. And China has excellent track record of delivering on these top-level aspirations. We see government support, and we see much less regulation and much less concern for some of the things we care about. We see a lot of data, and we see that, and at least with today's techniques, better data or more data means better trained product, which means more customers, which means more revenue, which means more engineers, and the cycle goes on and on. And so, so these are very interesting things to keep in perspective as we think about how we move in the space relative to China. Kai-Fu Lee makes some very powerful arguments by looking at the number of publications in the US versus China, the number of patents in the US versus China, the relative valuation of peer companies between American companies and Chinese companies that are getting to be one-to-one. So there's a lot of action in China. Now, Kai-Fu also suggests that maybe in the future, the US will stay ahead in innovation, and China will be ahead of us in productizing innovation, and this I take challenge with. I don't agree with him on, but we'll see how the world unfolds.
Joanne, I would love to hear from the MasterCard point of view, your take on.
I think Daniela makes a lot of good points, right? I think that China has set itself up to use all of the data inside of its own economy in a way that enables the innovation, right? And so if you think that AI learns from training data, and so the government has set up a society where all of the data is available for the training, right? And they have excellent data scientists, and so I think that is the positive of the system that China has set up, and so you're going to see all of that data be used for the ability to train and innovate. I think that, and look, MasterCard is a global company, and we work with governments all around the world, and we have to recognize that different governments have different advantages for different societies. I think that, though, Daniela is right. I don't know that any one government or society has a particular advantage at this point in time because it's early days, right? And so I think we're going to see different types of innovation pop up in different places. But I do think when it comes to the ability to harness the data in a society right now, that's what I think all the books are being written.
Do you see regulatory differences in the future?
Well, I think we're seeing, we heard the panel before, the convergence in privacy, convergence in some ways on security. I think what we're going to start seeing is some convergence on data regulation. Mm-hmm. I think that's where, we're talking about regulation for AI. I think you're going to start seeing baseline data principles needing to be enacted, but I'm not sure that we'll see it for AI specifically when I think that there's going to be some baseline data regulations.
I believe that data can't leave China right now.
No,
so
right.
there's
there's a lot of restrictions.
Eric, one sentence before I open it up to the audience.
One sentence that if you were to ask any lawyer, I see Anupam and Tim Wu and other lawyers in the audience, if you ask them, what's Kai-Fu Lee best known for? It's whether he could break his non-compete when he was switching jobs. And so I would say that part of this issue is also, how do we train sort of the human capital within the United States, within China, to basically take on whatever role we want them to be taking